Let's dive into the world of NoSQL databases. This is a new paradigm for modern data storage that goes beyond relational databases. First, let's discuss the limitations of relational databases. Relational databases often have rigid schema requirements, which means you have to define the structure of your data upfront. Scaling relational databases can be challenging, often requiring vertical scaling, which means upgrading to more powerful hardware. Relational databases can also be complex to manage unstructured data, and they can experience performance bottlenecks as the data grows. NoSQL databases offer several advantages. They provide flexible schemas, which allows your data structure to evolve over time. They support horizontal scaling across multiple servers, making them suitable for handling large amounts of data. NoSQL databases are optimized for specific data models, such as document, key value, column, or graph, leading to improved performance. They are better suited for high-volume and high-velocity data, where speed and scalability are critical. There are four main categories of NoSQL databases based on their data models. Document databases store data in flexible, JSON-like documents, where each document can have a different structure. Some examples include MongoDB, CouchDB, and Firebase. Key value stores use a simple data model that maps unique keys to values, providing extremely fast read and write operations. Examples include Redis, DynamoDB, and Ryak. Column family stores organize data into column families, optimized for queries over large datasets. Cassandra, HBase, and ScyllaDB are some examples. Graph databases store entities and the relationships between them, making them ideal for managing complex connected data. Examples include Neo4j, JanusGraph, and Amazon Neptune. Document databases offer flexible, JSON-like document storage. Key characteristics include schema-free document storage, where documents can have different structures and nested data structures. They are optimized for read-heavy workloads and support horizontal scaling through sharding. Document databases are commonly used in content management systems, e-commerce product catalogs, real-time analytics, Internet of Things applications, and mobile applications. As an example, here is a MongoDB document in JSON format. It has an ID, a title, author, published status, views, tags, and comments. The comments are also stored in the JSON document. Key value stores are simple, fast, and highly scalable. They are the simplest type of NoSQL data model, providing extremely fast read and write operations. Key value stores are highly scalable and distributed, with no schema or relationships between data elements. Values can be strings, numbers, JSON, or other data types. Key value stores are often used for caching and session storage, user preferences and profiles, real-time leaderboards, shopping carts, and high-speed counters in analytics. Here are some Redis examples: setting key value pairs using the set command, getting values by key using the get command, setting expiration using the ctext command, and incrementing a counter using the increase command. Column family stores are optimized for large-scale distributed data storage. In this type of database, data is stored in column families, providing sparse data storage, where only needed data is stored. They are highly scalable for large datasets and offer tunable consistency models. Column family stores are optimized for write-heavy workloads. Some use cases for column family stores include time series data, recommendation engines, sensor data and Internet of Things, event logging systems, and distributed systems with high write loads. Here is an example of the Cassandra data model. The data is stored in rows that have a key and multiple column families. Each column family contains columns with a name and a value. Graph databases are optimized for connected data and relationships. They store entities known as nodes and relationships between entities known as edges. Graph databases are optimized for traversing relationships and provide a natural representation of connected data. They offer powerful query capabilities for exploring relationships. Graph databases are used in social networks, recommendation engines, fraud detection systems, knowledge graphs, and network and information technology operations. Here is a graph data model example. There are person nodes, movie nodes, book nodes, company nodes, and city nodes. There are edges like friend of likes, works at, and lives in. Let's compare SQL and NoSQL databases to understand the key differences. SQL databases use relational tables with rows and columns for their data model. They have a fixed schema, meaning the structure is defined before data entry. They typically scale vertically, requiring more powerful hardware. SQL databases use structured query language or SQL for querying data. They have strong atomicity, consistency, isolation, and durability, often called ACID compliance. Examples include MySQL, PostgreSQL, Oracle, and SQL Server. NoSQL databases, on the other hand, use data models such as document, key value, column family, or graph. They have a schemaless or flexible structure that can adapt to data changes. They scale horizontally, distributing data across servers. NoSQL databases use database-specific APIs and query languages. Their ACID compliance is often relaxed for performance and scalability. Examples include MongoDB, Redis, Cassandra, and Neo4j. Let's delve into some NoSQL concepts, starting with the CAP theorem. In a distributed database system, you can only guarantee two of the following three properties simultaneously. Consistency, which means all nodes see the same data at the same time. Availability, which means every request receives a response, either success or failure. Partition tolerance, which means the system continues to operate despite network failures. In practice, partition tolerance is necessary for distributed systems, so the real choice is between consistency and availability. In NoSQL, the CAP theorem plays a significant role. Traditional relational database management systems, often called RDBMS, typically favor consistency and availability. CP systems like MongoDB and HBase favor consistency and partition tolerance. AP systems like Cassandra and CouchDB favor availability and partition tolerance. Let's see how NoSQL databases are used in the real world and discuss some key takeaways. NoSQL databases are used in big data processing to handle massive datasets with horizontal scaling and distributed processing capabilities. Examples of databases used are Cassandra, HBase, and MongoDB. NoSQL databases are also used in real-time applications, providing low-latency data access for applications requiring immediate responses and updates. Redis, DynamoDB, and Firebase are used here. Finally, NoSQL databases are used for social networks and recommendations, managing complex relationships, and personalized content delivery at scale. Some examples include Neo4j, MongoDB, and Cassandra. Key takeaways: NoSQL databases offer specialized solutions for specific data models and use cases. Choose the right database based on your data structure, access patterns, and scaling needs. Consider the CAP theorem trade-offs when designing distributed systems. Many modern applications use polyglot persistence, meaning they use multiple database types. SQL and NoSQL can complement each other in a well-designed architecture. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.